We've seen now a lot of different types of isomers, and it's now probably a good time to kind of summarize what type of isomers you may have in a particular molecule, comparing two different molecules. So the first thing that you want to do is see if they have the same molecular formula. And if they don't have the same molecular formula, then obviously they are not isomers. So that's the first and foremost thing. But if they do have the same molecular formula, then you have to ask yourself um, a series of questions. The first thing that you have to ask yourself is, are the atoms connected in the same way? Right? If they're not connected in the same way, then we call those isomers of one another constitutional isomers. So this is the difference between 2-methylpentane and 3-methylpentane. They are constitutional isomers. But if they do have the same atomic connections, right? All the atoms are connected in the same way. Then the next step is to say, well, are they superimposable on one another? If the answer is yes to this, then they have to be identical. And, maybe they are a meso compound if you have two or more stereogenic carbons. If they are not superimposable, then the question is, are they mirror images of one another? So if they're mirror images, if the answer is yes to that, then the two isomers are enantiomers of one another. And if the answer is no, they are not mirror images, then we see that they are diastereomers. Three different types of isomers that we've dealt with: constitutional isomers, and then stereoisomers, in which you have enantiomers that are mirror images and diastereomers that are not mirror images. So hopefully this helps in terms of trying to keep things straight and organized, and how gives you a process of how you figure out whether or not something is a stereoisomer or just a constitutional isomer, or maybe identical.